Alright, simplifying algebraic expressions number 2. We're going to talk more about inputting numbers into our variables or exchanging them for the variables. But let's just review here. I have a y plus y plus y. Now if you recall, our variables can be any letter of the alphabet. Today, at this point, we're using a y. This is, if we were just to use regular math, we could say y plus y plus y plus y and go on and on. But we want to simplify that, make it easier to use, less cumbersome. And of course, we need to employ our multiplication skills at this point. So instead of putting y plus y plus y, how many y's do we have here? We have 3 y's. I have 3 what? 3 y's. So this is the same thing as this, but this is our algebraic term. Alright, so if I were at this point now to say y equals 2, how do I input this 2 into my y? Well, here's a y right here. I have 3y. I could do 3 now. I know that I have the 3, it just brings down. My y at this point now is represented by the number 2. Parentheses, 2. What does this mean? That means 3 times 2. What is 3 times 2? 6. There we go. So now, let's think about something else. Let's simplify other terms. Let's talk more about combining like terms. So combining or combine like terms. Like terms means they're alike. They're like they have the same qualities. Alright, let's look at this one. If I have 2a plus 3a, are these like terms? Well, actually, yes, they are. They both have a coefficient, but they have the same variable. The variable is a. That means with addition, I can simply add my coefficients together. So 2 plus 3 is 5. I'm just going to use one of my a's because I know I'm doing addition. So it's 5a. So how many a's do I have altogether? If I have 2 a's here and 3 a's here, that's a total of 1, 2, 3, 4, 5 a's. So this is combining like terms, or I combine my like terms. Let's look at another example. If I have a plus 3a, this one's a little trickier. When I'm going to combine my like terms, I have to also know a few tricks. One of them being that when I have a variable in an expression like this, and there's no number in front of my variable, there's no coefficient in front of my variable, I have that imaginary 1 that's always in front of my variable. So even if this variable looks like it's loathsome, it's not. It has the friend number 1 always standing next to it. So now in this instance, I'm going to combine or look at combining like terms. Can I combine them? Well, they each have a coefficient, but what's more important is they both have the same variable, a. So here's 1a, here's 3 a's. So 1, 2, 3, 4 a's. Let's see if that holds true. What is 1 plus 3? That's 4, isn't it? 4 what? 4 a's. Is that true? 1, 2, 3. Yeah. 4 a's. So doing our model, I have 4 a's. Numerically or algebraically, if I did my process correctly, I also have 4 a's. So don't forget our imaginary 1 there. Let's see, what if I had this problem here? B plus 2b plus 3b. Again, we have to harken back to our imaginary 1. B is not by itself. It always has the friend here. Every variable always has its friend number 1. If he looks alone, he's not alone. He has a friend. So let's look at this. I have 1b here, 2b's here, and 3b's here. So this is my visual model. Alright, looking at this, I have 1, 2, 3, 4, 5, 6 b's. So I know I could put a 6 here. I have 6 what? 6 b's. Let me look at it numerically. I have a 1 here. 1 plus 2 is 3. 3 plus 3 is 6. 6 what? 6 b's. Are they the same? Yep, they are. There we go. So you can see that if we're having trouble figuring out what to do here, do your visuals. Write down how many b's each term is telling you. Remember, these are all called terms. Anything in our algebraic expressions are called terms. So this term is represented by this model and this model. So each term has its model. So go ahead, draw pictures. Do not be afraid to draw pictures. If you need to, do it. Alright, what if I had something like this? Again, thinking about combining like terms. If I had b or 2b plus 3x plus 4b. Now combining like terms. They each have a coefficient. That's cool. Alright. They each have a variable. I have a b, an x, and a b. Uh-oh. I see something different here. I see an x here. Is the x the same type of variable as b? Well, it is a variable, but it's not the same variable. So as far as like terms, I have 2 terms with the variable of b. These are the like terms that can be combined. Why don't I combine the 3x? It is a variable, but it's a different variable. Because if someone told me b equals 2, they're going to tell me that x equals a different number. X equals 3. Why can't x equal 2 as well? If x equaled 2 as well, we wouldn't need to write a different letter down. We wouldn't need a different variable. If x equaled 2, the same as b, this would be a b instead of an x. We could just say b. The reason we have variables is because the variables each represent a different number. Alright, so in this case, if I'm looking at 2b plus 3x plus 4b, we see that I can combine my 2b plus 4b. That would be 2 b's here, 4 b's here, so that's 6b plus, I'm going to box this together because this addition symbol is also a positive symbol. This means a positive 3x. So I'll put my addition or my positive sign here and 3x. 3x just is brought down because there is nothing I'm combining it with. It's standing on its own at this point. Alright, and you know what? Let's see if we can solve this. We know that b equals 2. So I'll do 6 I'll put in my parentheses 2. I'm substituting the b variable. I'm taking that out and putting in the 2 because my b equals 2. Plus, now I have a 3. I'm going to get rid of that x and substitute what I am told x equals, which is 3. Put that in parentheses. Again, what do the parentheses mean? It means you have that imaginary multiplication symbol. So what is 6 times 2? 12. Bring down the plus sign. What is a positive 3 times a positive 3? 9. Here we have like terms again. 12 plus 9. We have 12 and 9. So we just add that together. All right. What is 12 plus 9? 21. All right. So this not only showed us how to combine like terms, but it also showed us how to input numbers into our variables.